In the golden age of American V8s, Ford was building monsters, the kind of engines that made tires scream and rear ends dance. But by the mid-70s, that roar was starting to fade. The 351M and 400M rolled onto the scene at a time when performance was under attack from every angle. Smog laws, fuel shortages, insurance rates, and government red tape. What looked like two big block bruisers on paper turned out to be some of the most misunderstood engines Ford ever built. Some call them boat anchors, others call them underrated gems. The truth? It's messier and way more interesting than either side admits. To understand the Ford 351M and 400M, you have to step back into the early 1970s, a time of transition and turbulence for American automakers. Environmental concerns were rising. The oil crisis of 1973 had shaken the industry, and federal emissions regulations were tightening. Manufacturers like Ford faced a daunting task of creating engines that could power large vehicles while meeting stricter fuel economy and emission standards. It was within this storm that the 335 series engines, particularly the 351M and 400M, were born. Let's begin with the family tree. The M in both engines stands for modified, though that term has long sparked debate. Some say it means modified Cleveland, since both engines were descendants of the well-regarded 351 Cleveland introduced in 1970. Others argue it simply meant Michigan, after Ford's Michigan Casting Center, where both blocks were produced. The truth probably lies somewhere in between, but what's clear is that these engines were designed not from scratch, but as evolutions of an existing architecture adapted for new roles. The 400M was the first of the two to hit the market, debuting in 1971 as a replacement for the 390 FE engine in Ford's full-size cars and trucks. The goal was to create a big block alternative that was lighter, more cost-efficient, and easier to manufacture. The result was an engine that shared the 335 series architecture, but featured a tall deck block measuring 10.297 inches, compared to 9.206 inches in the 351C. This taller deck allowed for a longer stroke of 4.00 inches, giving the 400 cubic inches of displacement with the same 4-inch bore as the Cleveland. That longer stroke meant more low-end torque, ideal for heavier vehicles like Ford's LTDs, Galaxies, and F-Series trucks. Now enter the 351M, introduced in 1975. Unlike the 351 Cleveland or 351 Windsor, the 351M wasn't just another flavor of small block V8. It was essentially a D-stroked 400. It used the same tall deck block and the same large 3.00-inch main journals, but with a 3.5-inch stroke. This created 351 cubic inches of displacement, but with significantly different geometry than either the Cleveland or Windsor variants. Because it shared so many components with the 400, including the block, heads, and intake, it allowed Ford to streamline production and reduce parts complexity across their V8 lineup. From a corporate cost-cutting perspective, this made perfect sense. However, that design came with trade-offs. The tall deck block was heavier than it needed to be for a 350 Ci engine. The shared intake manifold between the 351M and 400 also meant a compromised port design, not optimized for high airflow or performance. The massive 3-inch main journals, while providing strength, added rotating mass that hurt high RPM responsiveness. In other words, these engines were clearly engineered for torque, not horsepower. Additionally, emissions and fuel economy concerns were already altering how Ford engineered their V8s. Lower compression ratios, often around 8.0 to 1, and restrictive camshaft timing became the norm, not by choice, but by necessity. Both the 351M and 400M came with retarded timing built into the camshaft and gear alignment to help reduce nitrogen oxide emissions. Again, great for regulators, not so great for performance. As a result, many owners in the late 70s were disappointed by how sluggish these large displacement engines felt compared to earlier big blocks from just a few years prior. Another point worth noting is that both engines were exclusively designed to work with Ford's newer bell housing bolt pattern. Unlike the 351C and most other small blocks that use the Windsor pattern, the 351M and 400M adopted the big block 429-460 bell housing bolt pattern. This further marked them as part of a new design lineage, intended primarily for truck duty, not racing or high-performance street applications. That's part of the reason why you rarely saw 351M or 400M engines in muscle cars or hot rods. They were simply not intended for that role, at least not from the factory. Interestingly, the cylinder heads on these engines retained some Cleveland DNA. Early 400s used 2V Cleveland-style heads with open combustion chambers, large ports, and decent flow, though later years saw emissions-era tweaks that further restricted power. The intake manifold for both engines was a unique cast that bridged the wide valley of the tall deck block, meaning no Cleveland or Windsor intake would bolt up without custom machining. All told, the 351M and 400M were clever, pragmatic adaptations of a powerful architecture that had to survive in a world growing increasingly hostile to performance. By the time the 351M and 400M were rolling out in the mid-70s, the muscle car era was all but over. The once thriving horsepower wars had ground to a halt. Not because enthusiasts stopped wanting fast cars, but because Washington started regulating how those cars were built. In the wake of the Clean Air Act and mounting concerns over air pollution, automakers like Ford were forced to prioritize emissions compliance over raw power. And that's where the story of the 351M and 400M takes a sharp turn. On paper, the 400M had the cubic inches to suggest serious muscle. 400 cubic inch was no joke, but when it came to performance, especially by the standards of just a few years earlier, both the 351M and 400M underdelivered. For example, in 1977, the 400M in a full-size Ford or Mercury might have been rated at around 170 horsepower and 300 pound-feet of torque. Numbers that sound modest today and were already considered disappointing back then. The 351M often hovered between 137 and 156 horsepower, depending on the year and application. Why the low output? A perfect storm of emissions-related constraints. First, compression ratios were slashed across the board. Whereas early 351 Cleveland engines had compression ratios well above 10-to-1, the 351M and 400M often saw ratios in the low 8-to-1 range. Lower compression reduces power, but helps prevent engine knock, especially with the lower octane unleaded fuels that became mandatory in 1975. It also helps reduce combustion chamber temperatures, a key factor in reducing NOx emissions. But all of that came at the expense of performance and efficiency. Second, the camshaft timing was deliberately retarded, literally engineered to open and close the valves later in the cycle. This strategy was used to reduce emissions but severely hurt throttle response and torque delivery at low RPMs. But the 351M and 400M engines were fitted with camshafts designed to meet emissions test requirements first and foremost, not to optimize power. Combined with restrictive exhaust manifolds and catalytic converters, these changes created engines that felt strangled compared to their free-breathing predecessors just a few years earlier. And then there was the issue of altitude tuning. Ford, like many manufacturers, had to adjust engine calibration depending on where vehicles would be sold. Engines destined for high-altitude states like Colorado or Utah had even leaner air-fuel mixtures and more retarded ignition timing, leading to even poorer performance. That means two identical cars, one sold in California and the other sold in Denver, could have noticeably different drivability. The detonation issue also loomed large. The move to unleaded gas gasoline and low compression should have made detonation a thing of the past, but the reality was more complicated. The lean burn strategies and hot-running exhaust gas recirculation systems often caused uneven combustion in the cylinders. Combined with carbon buildup in the combustion chamber, this led to occasional pinging under load, especially in hot climates or when towing, something many Ford truck owners in the late 70s experienced firsthand. So what you had by the late 1970s was an engine that looked big and tough but felt sluggish. The 351M and 400M were workhorses, yes, but they never lived up to the high expectations set by the Cleveland or Windsor before them. They weren't built to race, but they were built to survive EPA testing. In fact, many owners at the time didn't blame Ford for the weak performance. They blamed the government regulations and the oil crisis for neutering their V8s. And yet, despite all of this, these engines earned a reputation for durability in truck and heavy car applications. They weren't fast, but they could take a beating, especially when emissions gear was bypassed or replaced with aftermarket parts. Tuners eventually figured out how to retime the camshaft, improve carburation, and install performance intakes or headers, squeezing respectable power out of what was once a choked-up, gas-guzzling lump. While the 351M and 400M weren't known for exhilarating performance, they did earn a reputation for being rugged, at least in some respects. Built with thick cast iron blocks and heavy-duty internals, these engines could handle abuse, especially in truck applications. The large main journals and beefy bottom end were overbuilt for their modest output, which meant failures from sheer mechanical stress were rare. However, reliability wasn't bulletproof. One of the most persistent issues was the oiling system. Much like the 351C before it, the 351M and 400M suffered from oil delivery problems, particularly to the top end. Valve train wear became a common complaint, especially if owners pushed oil change intervals or used low-quality filters. Ford never fully resolved the oil flow issue from the Cleveland lineage, and it carried over here. Timing chain slack was another problem. Factory-installed chains were known to stretch prematurely, causing timing to drift, further weakening already anemic performance and sometimes leading to backfires or hard starts. Add in poor carburetor tuning, vacuum leaks from the maze of emission hoses, and hot start problems in warm climates, and you had a motor that, while tough at its core, needed regular attention to keep running smoothly. The Ford 351M and 400M weren't born to be legends. They were built to survive. In an era strangled by emissions rules, fuel crises, and fading muscle car dreams, these engines were a compromise. Big in displacement, low on performance, but built tough. While they never earned the glory of their Cleveland and Windsor siblings, they carved out a place as durable workhorses. Misunderstood, underappreciated, and now, strangely enough, kinda cool again. Don't stop following us. If you enjoyed the video, make sure to hit the like button and subscribe to this channel for more of our videos. See you in the next one.